Well, thank you so much for coming here and attending this talk on how apps can use advanced video experiences in Android and specifically on Snapdragon. And we realize that we are the only thing between you and happy hours, so we'll make it snappy. So yeah, my name is Raj, and I'm joined here by my colleague Vinay. And we're going to be talking about how developers can leverage the exciting new technologies that are available in Android mobile processors to enhance their applications. Specifically, we'll be talking about HDR formats, a recently introduced mobile codec, and an innovative way to reduce bandwidth for your video-based applications. Just a quick show of hands if any of your apps are actually using video, playback of video, or recording, or any other thing related to video. Oh, perfect. Thank you so much. So yeah, this hopefully will be a relevant talk for you guys. Before we move forward, I'd just like to talk to you about our company, Qualcomm, for a couple of minutes. It turns out that this last month, we turned 40. 40 years of fun-filled inventions and breakthroughs across technology. And we have done a lot of contributions in technology and invention for mobile, laptops, automotive, XR, IoT, and many other industries. Just a quick timeline of the company. We started it back in 1985, and now we've grown to a worldwide operation. Qualcomm is the developer of Snapdragon processors, which power more than 1 billion smartphones out there in existence right now. So there's a very good marriage of scale between Snapdragon smartphones and Android, the operating system, and the APIs that app developers use on a day-to-day basis. We have led the charge in 4G, 5G, and now hopefully 6G for speed and connectivity. But on the application processor side, we have a leading image sensor processor, and we can support 4K, 8K video, HDR10+, and various other HDR formats that are available through the Android HDR APIs. Like I said, Snapdragon powers more than 1 billion devices out there, Android devices, and it's a huge testament to the mobile reach of Snapdragon. And if you've used a Snapdragon or an Android phone, it's probably running a Snapdragon processor. Just a quick kind of overview of how we tier our products. The 8th tier is the one that powers most of the flagship phones out there. And then 7, 6, and 4 are subsequently for the sub-premium, the value tier, and so on. And then 4C is for the entry-level smartphones. So what we do is we'll invent our technology and introduce it through the 8th tier every year. And then it will percolate down to the lower tiers as we go on. Now you'll be thinking, how is this important to me? I'm a developer. And so the question we ask ourselves every day is, how do we bring the scale of our mobile processors to the developer community? And we answer this with 2 guiding principles. We enhance our developers' access to our market-leading technologies by working with you, the community, obviously. But we also co-design smartphones with our customers, like Samsung or Xiaomi, et cetera. And we also work very closely with the Google Android team. They are a very, very long and a very strong partner of ours. And number 2, the result of this kind of working together is a happy community and therefore a happy customer for Android phones. And specifically, our goals for developers are that your apps should be running perfectly on Android, and even better if they run somewhat more performantly on Snapdragon. So with that, let's go into the mobile video technologies. Nearly 50% of smartphone users record videos daily or weekly, especially the ones in the 18 to 34 age range. And then, according to statistics, people watch about 2.5 hours of mobile video daily on average. Those are some staggering numbers, and clearly it shows that video on mobile is an extremely important area for innovation, and where application developers could use as much performance as possible from their processors, from the processors underneath. And through advances in mobile technology, video technologies, a 2-hour-long 4K video, which would originally be 3.5 terabytes big, can be reduced to about 5 GB on a smartphone. And so a variety of technologies that are listed here come into play as we bring the size of the video down to something which is a manageable proportions. Over 87% of digital video creators have reported that they now record their videos on smartphones, especially Android devices, as their main tool for recording high video quality content. This marks a major shift from traditional DSLRs or cinematic cameras, and all of those optics, all of that processing power is now available in the palm of your hand. And it's very hard for people to spend a lot of money on these expensive cinematic cameras. And also the existing solutions really struggle to preserve high video quality as they go from capture to editing and then finally to playback. And so that is going to be our talk today, is how do we solve that problem. We will cover HDR technologies. We'll cover a brand new codec for mobile called APV. And then we'll talk about something that saves you a lot of bandwidth and storage costs. And we'll talk about this in the overall journey of recording a video, editing a video, and then playing it back. So let's start with HDR. I don't know if you can see this on this giant screen through the projector, but the one on the left is much more richer in its quality than the one video on the right. Obviously, the one on the left, it has been captured with HDR10 on a Snapdragon, 10 Plus on a Snapdragon phone, and the one on the right hasn't. And I'd kind of like to give this analogy that HDR makes things bright and colorful. Imagine you're painting on a piece of paper, and if you use bright, shiny colors or extra colorful markers, the result will be much more pleasing to the eye. There will be brighter brights, darker darks, and just more colors popping up. And so a smooth sunset would look more glowy, shadows would look deeper in real life. And so that is the promise of HDR. And if your application is a video app or an image processing app, then HDR should definitely be on your roadmap. And Android offers a lot of these HDR APIs, and I'll go over them shortly. So for capture and editing, you have HDR10 Plus and various other formats like HDR10, HLG, Dolby Vision, etc., all available throughout our product roadmap. And they have been available in Android since Android 13. So now we're in Android 16 now. So 3 years ago, there's millions of phones out there which have this technology inbuilt. And so if your applications want to use HDR, you can have it. And it's even more prevalent for HDR video playback, where the support has been there since Android 7. So more than almost 10 years now. And so there's literally hundreds of millions of phones out there where you can do HDR playback now. All you have to do is go to the Android website and use the HDR APIs there. We'll talk about the APIs in a minute. Now we're going to talk about advanced professional video. This is a brand new video codec that dropped very recently. It's been defined by Samsung, and developed or implemented in hardware by Qualcomm. In fact, hot off the press, we just announced this at another event just a few hours ago. So you guys are the lucky few ones to take a look at this. So I'll just play this video really quick. This was shot on a Snapdragon latest and greatest chipset that launched yesterday. And it shows that you can have the power of a film crew now in your pocket, in a phone coming close to you very soon. So what is APV? It's, again, like I said, it's a video codec, and it is defined by Samsung, which is a partner of ours, but developed in hardware by Qualcomm. It's an intra-frame only codec, which means that each frame is coded independently of every other frame. It's low complexity, and it's flexible and extensible. How does it benefit you, the developer? It allows easy access to any frame during editing, so you don't have to worry about the previous frame or the next frame. You just think about the current frame. It's royalty-free, obviously, so it's free to use, and that's a very big draw for APV. And it supports 8K and 10 or 12-bit depth resolutions, offers very high dynamic range, and it's available on Android 16, so you don't have to go access any kind of vendor-specific APIs, just available. Not only that, we are very proud that we launched 8 Elite Gen 5, the latest flagship Snapdragon processor yesterday, and it has APV hardware support on it, which will lead to significantly improved battery life. It will maintain very high performance, and then your file sizes for your video now will be 10% smaller than if you capture with ProRes. And finally, we have been working with a lot of industry partners to build an ecosystem around APV, such as Samsung, which obviously has defined it, but also Android, and now Android APIs are available in Android 16 for you. But not only that, we are working with various editing software vendors, as well as playback software vendors, to bring the APV workflow, professional video workflow, to everyone and democratize it. We welcome you to also try it out. Just a quick example of it. On the right, you have, I'm not sure if you can see the subtle differences here on this big screen, but on the right, we tried to show an APV snapshot compared to an HEVC snapshot on the left. With lower bit rate, you can get greater clarity with APV than HEVC, which is super interesting. And so I wanted to tie it all together in a developer's workflow. So how does it all come together? With Android 16 now, with the APV APIs, your apps can now record, edit, and playback professional video quality content without needing to transcode at any point during the editing phase, which is a huge unlock. And the best part, it's available on Snapdragon-powered phones, available and coming to users near you very shortly. And now the third thing that I wanted to talk to you, which is also super compelling, is region of interest-based coding. What this is it encodes specific areas of the frame which are more likely to be seen by the consumer in higher quality, and then for the rest of the areas, you can encode them in a slightly lower quality. What this adaptive kind of encoding does is it will save bandwidth and storage costs. Super, super critical for something that has applications that are more video intensive, maybe a video conferencing app or a security or a surveillance app. And it's available since last year, Android 15, and it's just ready to go for you. So again, it's accelerated in hardware. It's not a software codec. And so this leads to increased performance and better efficiency. I'll just put a brief illustration here. The way you do it is in software, you would define a square or a region of interest. You give the coordinates to the hardware block, and then only within that hardware block you'll see that the quality is the encoding quality is much better than for the rest of the image, where the user's eyes will usually not gravitate. And so this will lead to much smaller file sizes and better bandwidth requirements. So yeah, this was in a nutshell at a high level how these features are now showing up and available for the community. And I will invite Vinay to come over and talk about the APIs for these.
Thanks, Raj. Thank you for all the details you provided. So just as a developer, right, I'll be more focusing on the APIs. But just before I begin, you might be asking a question that, hey, we have like Google-supported software codecs. There's FFmpeg available. What are you guys talking about, right? Yes, these are supported. All the quality features come on FFmpeg, the software codecs, which are on a stock Android build. But what we offer on Snapdragon is a better performance with a lower power. So if you are building an app, and if you are using any of these software codecs, and if they are draining the battery, I don't think anybody would use it, right? But if you're running on the Snapdragon, the same APIs would use the hardware acceleration, which reduces the power. And that's a big advantage that we would have. Right? So going into the APIs for the HDR, so is anybody having an app for like video recording with HDR? Or is anybody planning to have it? Or anybody using it? OK, so I'll go a little bit deeper in the explanation then. So for HDR, there are a couple of things, right? One is basically you have a camera which need to capture it in a HDR format, and then send those captured frames to the video encoder, where the video encoder needs to encode it. And at the same time, the camera needs to provide some additional metadata so that the video encoder puts it into your MP4, so that when you play back it on any other device which has HDR capability, ideally, it should be able to display those vibrant colors and the contrast, dynamic contrast, whatever was encoded on the HDR-capable device. So nowadays, I think like pretty much all the flagship phones, they come with the HDR-capable recording. And even Samsung might be just putting it as a default setting in their next phones, so that all your apps or any app will just record it in HDR. So going into the APIs itself, if you see there is like, this is mostly the camera setup. So there's a query API, which can use to query whether the camera on the device supports these dynamic range profiles. And if the device is capable of providing the HDR recording or the HDR capture itself from the camera side, then you can select your profiles. So usually, there are 3 profiles. One is the HLG, HDR10, and HDR10+. So there are some differences between the profiles. So the best quality what we get on per frame basis is with the HDR10+, because the metadata which is getting generated is on a per frame basis. So that means when it's getting displayed, uh, the tone mapping on the display side is happening on a per frame basis. So you get a better quality compared to HDR10, which is like just a static metadata which applies to your complete video sequence or the video file which you have recorded. So let's say we select the HDR10 Plus profile. It's supported. Now we have to set up the camera. So there are camera 2 APIs in the stock Android that we can use to set this dynamic range profile to it. And with this, the camera is capable of capturing it. The next thing is, now we have to set up the encoder also so that it encodes in the HDR format. The same profile we could use for either HLG, HDR10, or HDR10 Plus. And these are all the standard APIs that Android provides today for using the media format. You can set either so the example here is HEVC profiles, but similar profiles exist for all other codecs also. Once you set up this media format, and you can create a HDR encoder with that profile using this API, where you set that format to the encoder. So, and then you have the camera, you have the video set up, everything for HDR recording. So now, so you might ask, like, this is for the camera, but what about if I'm using for some other application where I'm transcoding from one file to the other, and I want to make it a HDR10 Plus compatible file. So for that, because you were transcoding, you might be editing it some editing, or you might be doing some color conversions between, after you decode, you might be adding some logos, you might be adding some, like you might be running some AI models on that and adding some additional data. So the original HDR10, which it was captured, it doesn't apply anymore in a sense that it has to be regenerated. So for this, we have additional APIs that Qualcomm provides as part of the vendor extensions, where we can regenerate it. So there are two ways. One is you just provide the HDR profile, and automatically it will regenerate using the GPU. And more specifically, if you want to use the hardware, which is more relevant because you want the metadata to be generated just before it gets encoded. So because that's the right place that it has to get generated and applied, and you encode the file. So we have this vendor extension, which you can set to generate the HDR10 Plus. So this would use the hardware to generate it. Moving on, so similar to HDR10 Plus, we also support Dolby Vision. And it's pretty straightforward for Dolby Vision as well, is that instead of HEVC, Dolby Vision has defined a separate MIME type, and it's already available in the Android APIs. We could just use that MIME type to record. Instead of HEVC, you just use a Dolby Vision profile for that. And similarly, you just set the media format with that MIME type, and then you're good to record it. So comparison between HDR10 Plus and Dolby, I think some people like Dolby better because it provides more sophisticated metadata generation algorithms. But some people still like HDR10 Plus. Okay, so moving on to the APV, as Raj mentioned, I mean, like, this is a brand new codec that Qualcomm just announced, and the hardware support is there. Also, it comes with the software codec support on Android 16. So one of the thing is when you're running a software codec-based codec on your device, we won't get the full performance out of it. So you might just be able to record a full HD, a 1080p recording. But if you want to go beyond that with 4K and 8K, you would need the hardware acceleration. But that's happening under the hood, so your app doesn't need to even worry about it. So the new APIs that Google has introduced is, if you see that there is a new MIME type, which is called the video/APV. So that's the new MIME type that we would be using. And there are I think you guys know that there are a couple of ways that you can use the Android APIs. One is on the media codec side. The other one is on the recording side, media recorder side. So, so media codec side, you just use that MIME type as part of your format, and you create that codec. Media recorder, it's straightforward. You just define, set the video, set video encode, and you use the APV as your codec type. This is extending the HDR profiles to APV. APV is already lossless, but then adding HDR to it makes it more vibrant. And when you are editing it, it's really useful if you are doing HDR editing. So here's just an example of you have an HEVC, which we went through earlier, where you have enabled all these HDR profiles for it. It's really simple to move it to APV. APV also defined some of the profiles for HDR already. We just call into that, set up the media codec, and we just use the standard APIs to create the encoder and start the recording. As Raj touched upon ROI, so this is also standardized now on Android 16 onwards. So if you'll see this picture here, there are a couple of ways that you can define your region of interest. One is on the left side, where you define the complete map for that particular video frame, wherein each block you see is pretty much like a 16 by 16 pixel grid. And you specify the QP offset value for each. So ideally, a lower QP value means a higher quality. So if your region of interest is kind of covering the dog and the cat there, so you can define those particular macro blocks and then reduce the QP values for it while you're using the APIs and setting it. That means on your recorded clip, you will see a better quality for that portion of the image compared to the rest of it. The other way is you can define multiple rectangles and specify the QP for each rectangle, and the rectangles can be overlapping. So this doesn't give exactly the flexibility as the map, but still it does its job. You can set multiple rectangles and then specify the QP for this. So currently, both the APIs are standardized, and that can be used. So let's look at the standard APIs first. So as I was explaining that, you can set the lower QP values for the region of interest, where it's kind of encoder puts more bits into it. So more bits is better quality. So you can use the APIs here where you define the rectangles. So it's kind of, you define the offset for left and right, and then the width and height of the rectangle. So here is where you define the ROI rectangles, and then you use this standard key to configure the rectangle to that encoder. And this is like a sticky configuration. Once you configure it, it stays until you configure for the next one. So you might be running some AI model in the background where you want to select your salient region or your region of interest based on the content, and then you can set the map or the rectangle for that. On the similar lines, this is for the QP offset map. So the map, you would have to create a complete grid of 16 by 16 for the whole frame, and then you specify the QP offsets for each of them. So before it was standardized, Qualcomm, we were supporting this ROI from API 31 itself. But we are still continuing to support that, although there are the standard keys. So either you can use this or the standard keys, but these are like our vendor extensions that we supported in our previous generation of the chipset. And we still continue to support this. And yeah, I think happy hour is nearing, so we are going to the last slide here. So these are all the links which you can use to get more information on the things we have talked about for APV, HDR support, and the ROI. I think that's pretty much it. And if you want to join our developer community, please scan the QR code from here, and we'll talk more, and we'll discuss more, and let's get better quality out on our Android phones. Thank you.